question at hand pertains to the installation of a smoke detector above a suspended ceiling in a corridor, specifically on the underside of a concrete slab. The electrical contractor proposes mounting the smoke detector on a 4" by 4" box attached to a 3/4" electrical metallic tubing, or EMT, configured as the flagpole. The EMT is bent so that the vertical portion can be secured to the side wall above the suspended ceiling, positioning the detector in the center of the corridor against the concrete slab. The base of the EMT is attached to the gypsum board side wall using two mineralac straps approximately 6 inches apart, leaving the remainder of the assembly unsupported. The wiring for the detector is wire tied to the EMT and enters the box through a grommet, effectively meaning the wiring is not running inside the conduit. The concern raised is whether this box support method complies with the National Electrical Code, specifically Section 314.23a, which addresses box support requirements. The electrical contractor believes their method complies with 314.23b. The core question revolves around the interpretation of the term rigidly. Rigidity in this context means not easily bent or distorted. While 3/4" EMT is generally considered rigid, the use of only two mineralac straps for attachment may not provide sufficient rigidity, particularly for the unsupported portion of the conduit. NEC Section 314.23 stipulates that boxes must be rigidly and securely fastened. Since the box is supported by the EMT, and the EMT is attached to the wall with mineralac straps, it could be argued that the box is rigidly fastened. However, the lack of support for the remaining length of the conduit introduces flexibility, raising concerns. NEC Section 314.23b permits boxes to be attached to a rigid bar or other rigid means of support. The EMT could be considered a rigid means of support. However, the sufficiency of the two mineralac straps to support the entire assembly remains questionable. There are several concerns regarding this installation. Firstly, stability. The assembly's stability may be inadequate, especially when subjected to vibrations or other disturbances. The unsupported portion of the conduit could sway, potentially causing the box to move and damaging the detector or wiring. Secondly, maintenance. Servicing the detector could be difficult due to its location and a lack of adequate support. Thirdly, code interpretation. The installation method falls into a gray area of the code. While not explicitly prohibited, it raises concerns about compliance with 314.23a. It is recommended to install the smoke detector according to the manufacturer's instructions. These instructions typically require a securely fastened box directly attached to the ceiling. This method ensures both rigidity and stability, preventing potential code compliance issues. Let's delve deeper into the specific code sections to fully understand the requirements and potential implications. NEC 314.23 covers the support methods for outlet, device, pull, and junction boxes, conduit bodies, and fittings. It aims to ensure that these components are securely and reliably mounted to prevent hazards like loose wiring or falling equipment. Subsection 314.23 specifically addresses boxes fastened to surfaces. It mandates that boxes be rigidly and securely fastened to the surface upon which they are mounted. This section emphasizes a direct and robust connection between the box and the building structure. The proposed installation deviates from this requirement as the box is not directly attached to the ceiling but rather supported by an EMT conduit extension. Subsection 314.23b provides alternative support methods, allowing boxes to be supported by structural members or independent supports. This subsection requires that the box be supported by a rigid bar, cable, or other rigid means. The electrical contractor is likely arguing that the EMT conduit acts as the rigid means of support. However, the code also emphasizes that the support must be adequate to withstand the expected forces. In the proposed installation, the adequacy of the two mineralac straps to support the entire weight of the box, detector, and conduit, while also resisting any swaying or vibration forces, is questionable. The code does not explicitly define rigidly, but the general understanding is that the support should be firm, unyielding, and resistant to movement. The installation's flexibility, due to the unsupported length of the EMT, suggests that it may not meet this definition. Considering the potential for movement and the difficulty in servicing the detector, the proposed installation presents practical concerns beyond strict code compliance. Vibration, even from normal building operations, could cause the EMT to sway, potentially loosening the mineral straps or damaging the wiring connections within the box. Accessing the detector for testing or replacement would require maneuvering within the confined space above the suspended ceiling, potentially straining the EMT support and further compromising its stability. A more robust and code-compliant solution would involve directly attaching a suitable support structure to the concrete slab above the suspended ceiling. This could involve using concrete anchors to secure a unistrut channel or other support system. The box could then be securely mounted to the support structure, ensuring a rigid and stable installation. Another option would be to use a telescoping support rod that extends from the floor to the concrete slab. The box could be mounted to the top of the rod, providing a stable and easily adjustable support. Regardless of the chosen method, it is crucial to ensure that the support structure is adequately sized and rated to handle the weight of the box and detector, as well as any potential forces from vibration or accidental impact. The installation should also comply with all applicable local codes and regulations, which may have additional requirements beyond the NEC. In summary, while the proposed installation may not be explicitly prohibited by the NEC, it raises significant concerns regarding rigidity, stability, and ease of maintenance. A more robust and code-compliant solution is recommended to ensure the long-term reliability and safety of the smoke detector system. Let's consider the broader implications of non-standard installations and their impact on safety and code enforcement. The NEC is designed to provide a minimum standard for electrical safety, protecting people and property from hazards. Deviations from these standards, even if seemingly minor, can create unforeseen risks and compromise the overall safety of the electrical system. Code enforcement officials play a critical role in ensuring that electrical installations comply with the NEC and other applicable codes. They review plans, conduct inspections, and issue permits to verify that the work is performed safely and correctly. When encountering non-standard installations, code officials must exercise their judgment to determine whether the installation meets the intent of the code and provides an acceptable level of safety. In this particular case, a code official would likely question the rigidity and stability of the proposed smoke detector support system. They may require the electrical contractor to provide additional documentation or testing to demonstrate that the installation is adequate. If the code official is not satisfied with the documentation or testing, they may require the contractor to modify the installation to comply with the code. It is important for electrical contractors to work closely with code officials to ensure that their installations meet all applicable requirements. This collaboration can help to avoid costly rework and ensure that the electrical system is safe and reliable. In addition to code compliance, electrical contractors also have a responsibility to provide their customers with high-quality workmanship and professional service. This includes using appropriate materials and methods, following industry best practices, and addressing any concerns or questions that the customer may have. By adhering to these principles, electrical contractors can build trust with their customers and establish a reputation for excellence. Let's explore some alternative methods for supporting smoke detectors in similar situations where direct attachment to the ceiling is challenging. One common approach is to use a pendant-mounted smoke detector. This type of detector is suspended from the ceiling using a chain or cable. The chain or cable can be attached to a structural member above the suspended ceiling, providing a secure and stable support. Pendant-mounted smoke detectors are particularly useful in areas with high ceilings or where there are obstructions that prevent direct attachment to the ceiling. Another option is to use a surface-mounted smoke detector with a remote test switch. This type of detector is mounted in the wall and connected to a remote test switch that is located at a more accessible location. The remote test switch allows building personnel to test the detector without having to climb a ladder or access the area above the suspended ceiling. Surface-mounted smoke detectors with remote test switches are often used in hospitals, schools, and other facilities where regular testing is required. In some cases, it may be necessary to install a dedicated support structure for the smoke detector. This could involve using either strut channel or other framing material to create a platform that is securely attached to the building structure. The smoke detector can then be mounted to this platform, providing a stable and reliable support. Dedicated support structures are typically used in areas where there are no suitable existing structural members or where the smoke detector is particularly heavy or bulky. When selecting a support method for a smoke detector, it is important to consider the following factors. Firstly, the weight and size of the detector. The support structure must be able to safely support the weight of the detector without sagging or failing. Secondly, the environmental conditions. The support structure must be able to withstand the environmental conditions in the area, such as temperature, humidity, and vibration. Thirdly, accessibility. The support structure must allow for easy access to the detector for testing and maintenance. Fourthly, code compliance. The support structure must comply with all applicable codes and regulations. By carefully considering these factors, electrical contractors can select a support method that is safe, reliable, and code compliant. In addition to selecting an appropriate support method, it is also important to use high-quality materials and workmanship. This includes using corrosion-resistant hardware, properly tightening all connections, and ensuring that the installation is neat and professional. By paying attention to these details, electrical contractors can ensure that the smoke detector system will provide reliable fire protection for years to come. Let's discuss the importance of proper wiring methods for smoke detectors and how they relate to the overall safety of the system. The NEC contains specific requirements for wiring smoke detectors, including conductor size, insulation type, and wiring methods. These requirements are designed to minimize the risk of electrical shock, fire, and other hazards. One important requirement is that smoke detector wiring must be installed in accordance with Chapter 3 of the NEC, which covers wiring methods and materials. This means that the wiring must be properly protected from physical damage, moisture, and other environmental factors. Common wiring methods for smoke detectors include using non-metallic sheath cable or NM cable in dry locations and electrical metallic tubing or IMS, or rigid metal conduit or RMC in wet or hazardous locations. The choice of wiring method depends on the specific application and the environmental conditions. Another important requirement is that smoke detector wiring must be properly supported and secured. This helps to prevent the wiring from sagging, rubbing against sharp edges, or becoming damaged in other ways. The NEC specifies the maximum spacing for supports and the types of supports that are permitted. In addition to following the NEC requirements, it is also important to follow the manufacturer's instructions for wiring the smoke detector. The manufacturer's instructions may contain additional requirements or recommendations that are specific to the detector model. It is crucial to carefully read and understand the manufacturer's instructions before installing the smoke detector. When wiring smoke detectors, it is also important to pay attention to the polarity of the connections. Smoke detectors typically have separate terminals for positive and negative conductors. Connecting the conductors with the wrong polarity can damage the detector or prevent it from functioning properly. It is always a good practice to double-check the wiring connections before energizing the circuit. Another important consideration is the use of smoke detectors with battery backup. These detectors are equipped with a battery that provides power in the event of a power outage. The battery backup ensures that the smoke detector will continue to function even when the main power supply is interrupted. When installing smoke detectors with battery backup, it is important to ensure that the battery is properly installed and charged. The battery should be replaced periodically, typically every 6 months or as recommended by the manufacturer. It is also important to test the smoke detector regularly to ensure that the battery backup is functioning properly. By following these guidelines, electrical contractors can ensure that smoke detector wiring is installed safely and reliably. Proper wiring methods are essential for the overall safety of the smoke detector system and for the protection of building occupants. Let's examine the role of regular inspection and testing in maintaining the effectiveness of smoke detector systems. Smoke detectors are critical life safety devices that require regular inspection and testing to ensure they are functioning properly. The National Fire Protection Association, or NFPA, provides guidelines for the inspection, testing, and maintenance of smoke detectors in its standard NFPA 72, National Fire Alarm and Signaling Code. NFPA 72 recommends that smoke detectors be visually inspected at least monthly to ensure that they are free from obstructions, dust, and other debris. The inspection should also verify that the detector is securely mounted and that there are no signs of damage. In addition to visual inspections, smoke detectors should be tested regularly to verify that they are capable of detecting smoke and activating the alarm. NFPA 72 recommends that smoke detectors be tested at least annually using a calibrated test instrument or by using the detector's built-in test function. The test should verify that the detector is sensitive enough to detect smoke and that the alarm is loud enough to be heard throughout the protected area. For smoke detectors in residential occupancies, NFPA 72 recommends that the detectors be tested monthly by pressing the test button. This simple test can help to identify detectors that are not functioning properly. In addition to regular inspection and testing, smoke detectors should be cleaned periodically to remove dust and debris that can interfere with their operation. NFPA 72 recommends that smoke detectors be cleaned at least every 6 months using a vacuum cleaner with a brush attachment. The cleaning should remove any dust or debris from the detector sensing chamber and vents. Smoke detectors should also be replaced periodically, typically every 10 years, or as recommended by the manufacturer. Over time, smoke detectors can become less sensitive to smoke due to aging and contamination. Replacing the detectors ensures that they will continue to provide reliable fire protection. Building owners and managers have a responsibility to ensure that smoke detectors are properly inspected, tested, and maintained. This includes developing a written inspection and testing plan, training personnel to perform the inspections and tests, and keeping records of the inspections and tests. By implementing a comprehensive inspection and testing program, building owners and managers can help to ensure that smoke detectors are functioning properly and providing reliable fire protection. In addition to following the NFPA 72 guidelines, it is also important to comply with all applicable local codes and regulations. Some jurisdictions may have additional requirements for the inspection, testing, and maintenance of smoke detectors. By staying informed about the latest codes and regulations, building owners and managers can ensure that their smoke detector systems meet all applicable requirements. Regular inspection and testing are essential for maintaining the effectiveness of smoke detector systems. By following the NFPA 72 guidelines and complying with all applicable local codes and regulations, building owners and managers can help to protect building occupants from the dangers of fire.